The slope of the wage schooling locus tells us how much earnings increase if the worker spends an additional year in school. We can also display that in terms of percentage increase in wages. So the marginal rate of returns to school is what we call the percent change in earnings from one more year of school. Let's suppose the worker has a full ride scholarship. So for them, they don't have to worry about tuition. The only cost to attend school is a foregone income during their education period. Because the previous slide showed decreasing marginal returns to education and it was concave, that means that the marginal rate of return is downward sloping, which we see here. This is by definition. Really, they mean the same thing. So this curve shows the same basic concept, but now the returns are expressed in percents instead of totals. A worker maximizes the present value of their lifetime earnings by going to school until the marginal rate of return to schooling equals the discount rate. A worker with a discount rate R goes to school where that crosses the marginal rate of return curve right here. That corresponds with S star years of schooling. If the discount rate is higher, let's say R prime up here, we trace that to where it crosses the marginal rate of return curve. Follow it all the way down to the years of schooling. The higher discount rate corresponds to fewer years of schooling. When individuals decide how many years of schooling to pursue, they're making a decision about investing in their own future. But not everyone views this decision the same way because people value the future differently. This is where our discount rate comes in. So remember, it tells us how much a person values the future benefits relative to today's costs. So let's compare two people. In this example, it's Al and Bo. Al had a high discount rate, so dropped out of school after 11th grade. But Bo stuck it out through high school and he graduated. So on the left, we see the marginal rate of return to school. Al here has the higher discount rate. Here's Al's discount rate. We see that corresponds to 11 years of schooling. Bo, on the other hand, had a lower discount rate. When you trace that over, that corresponds to 12 years of schooling. So that just graphically shows the decision that I just described. Now we can see that their decision-making process, we can also turn to how it impacts their career earnings. So Al only has 11 years of education. So if we look at the years of schooling here, he has 11 years of schooling. As we trace that up to the curve, we see that this shows the wages that Al receives. Unsurprisingly, Bo, who's gone through more years of schooling, is at a higher point on this curve. So Bo's wages up here are higher than Al's wages because Bo had more years of education, developed their skills more. They're now more productive and a greater value to whatever firm they'll be working for. Now, what happens if the government notices this and tries to help Al by passing a law that requires all students to graduate high school to stick it out through the end? It would be tempting to say that Al would receive the same wages as Bo, that it would just move him from point P here. Now that we're up to the 12 years of schooling, that he would be up here, the same as Bo, and receive the same wages. If 100% of the earnings difference is related to education and no other characteristics between Al and Bo, then that would be true.